Imagine holding in your hand a metal so light it could float on water, so reactive it bursts into crimson flames when exposed to air, yet so powerful it's reshaping the entire future of human civilization. This isn't science fiction. This is lithium, element number 3 on the periodic table, and right now, at this very moment, you probably have several grams of it within arm's reach. Look at your phone, your laptop, maybe even your watch. Inside those sleek devices lies a revolution powered by one of nature's most extraordinary elements. But here's what will blow your mind. What we're using lithium for today is just the beginning, and the race to control this silvery white metal might determine which nations lead the world economy for the next century. So what makes lithium so incredibly special? And why are countries literally going to war, economically speaking, to secure their supply? Stay with me, because by the end of this video, you'll never look at your smartphone the same way again. Let's start with something that sounds almost magical. Lithium is the lightest metal on Earth. I mean, genuinely, remarkably light. If you could hold a pure chunk of lithium in your hand, which you absolutely should not do without serious protective equipment, it would feel almost unnaturally weightless, like holding a piece of dense foam rather than metal. It's about half the density of water, which means if you dropped it in a bathtub, it would literally float. But don't try this at home, because within seconds that innocent-looking metal would start violently reacting with the water, fizzing, smoking and dancing across the surface while releasing hydrogen gas that could ignite into those spectacular crimson flames I mentioned. This combination of being incredibly light and incredibly reactive is precisely what makes lithium so valuable, especially when we talk about storing energy. Now, before we dive into all the mind-blowing applications, let me take you back in time for a moment, because the story of how we discovered lithium is fascinating. Picture this. It's 1817 in Sweden, and a young chemist named Johann August Arfwedson is working in the laboratory of the famous chemist Jöns Jacob Berzelius. Arfwedson is analyzing a mineral called petalite, and he notices something strange. The mineral contains an unknown element, something no one had ever identified before. He calls it lithium, from the Greek word lithos, meaning stone, because unlike the other alkali metals that had been discovered in plant ashes, this one came from solid rock. Here's the amazing part. Despite discovering it in 1817, it took nearly a century before anyone really figured out what to do with it. For decades, lithium was basically just a laboratory curiosity, a weird light metal that scientists played with, but that had no practical purpose. How times have changed, right? The first major application for lithium wasn't what you'd expect. In the 1940s and 50s, doctors noticed something remarkable. Lithium compounds had a powerful effect on mood disorders. An Australian psychiatrist named John Cade made this groundbreaking discovery almost by accident while researching the uric acid levels in patients with mental illness. He used lithium urate as a control in his experiments and noticed it had a calming effect on guinea pigs. When he cautiously tried it on patients with bipolar disorder, then called manic depression, the results were stunning. People who had been trapped in devastating cycles of mania and depression found stability for the first time in their lives. Today, lithium carbonate and lithium citrate remain among the most effective treatments for bipolar disorder, helping millions of people worldwide maintain balanced mental health. Think about that for a second. The same element that powers your devices is also helping to balance the neurochemistry in human brains. If that's not incredible, I don't know what is. Drop a comment below if you or someone you know has been helped by lithium treatment, because this medical application literally saves lives every single day. But let's talk about what's really driving the lithium revolution. The application that's causing nations to scramble for supplies and companies to race across deserts and mountains searching for new deposits. I'm talking about batteries, specifically lithium-ion batteries. And to understand why these batteries are so game-changing, you need to understand what makes a good battery in the first place. A battery is essentially a device that stores chemical energy and converts it into electrical energy when you need it. The key metrics are energy density, which is how much energy you can pack into a given weight or volume, and the number of times you can charge and discharge the battery before it degrades. For decades, we used batteries based on lead, nickel, cadmium, and nickel metal hydride. They worked, but they were heavy, bulky, and couldn't hold that much charge relative to their size. Enter lithium. Remember how I said it's the lightest metal on Earth? That's crucial here. In a battery, Lithium ions, which are lithium atoms that have lost one electron, can move back and forth between two electrodes through an electrolyte solution. During charging, lithium ions move to the negative electrode, called the anode, usually made of graphite. During discharge, when you're actually using the battery, those ions flow back to the positive electrode, the cathode, typically made from lithium combined with other metals like cobalt, nickel, or manganese. This flow of ions creates an electric current that powers your device. Because lithium is so light and because each lithium atom can store a relatively large amount of energy for its weight, lithium-ion batteries have an energy density that absolutely demolishes older battery technologies. We're talking about 3 to 4 times the energy density of older rechargeable batteries. This means your smartphone can run all day despite being impossibly thin. Your laptop can last for hours without being a 20-pound brick. And, this is the big one, electric vehicles can actually travel reasonable distances without weighing as much as a small building. The electric vehicle revolution is perhaps the most visible and dramatic example of lithium's impact on modern life. Before lithium-ion batteries became practical and affordable, electric cars were basically golf carts with delusions of grandeur. They were slow, had pathetically short ranges, and took forever to charge. But modern electric vehicles powered by advanced lithium-ion battery packs can now travel 300, 400, even 500 miles on a single charge, accelerate faster than most sports cars, and charge up in the time it takes to grab a coffee. Companies like Tesla, BYD, Rivian, and traditional automakers who are rapidly electrifying their fleets are all engaged in a massive competition to secure lithium supplies. And here's where it gets really interesting. A single electric vehicle battery pack contains approximately 8 to 10 kilograms of lithium. That's the actual elemental lithium content, though the total lithium compounds in the battery weigh much more. Now multiply that by millions of electric vehicles being produced every year, and you start to understand why lithium is being called white gold, and why it's triggering what some are calling the resource rush of the 21st century. But where does all this lithium actually come from? This is where the story gets geologically fascinating. Lithium doesn't exist in pure form in nature because it's way too reactive. Instead, it's found in two main types of deposits: hard rock minerals, particularly one called spodumene, and in brine deposits, which are basically super salty water trapped underground or in salt flats. The largest and most famous lithium brine deposits are in South America, in a region called the Lithium Triangle, which spans parts of Argentina, Bolivia, and Chile. If you've ever seen those stunning photographs of the Salar de Uyuni in Bolivia, with its endless white expanse that looks like another planet, you're looking at one of the world's largest potential lithium reserves. These salt flats, or salars, contain brine rich in lithium chloride. To extract it, companies pump the brine into enormous shallow ponds, where the brutal Andean sun slowly evaporates the water over months or even years, concentrating the lithium until it can be processed. It's a method that requires very little energy, which is great, but it uses tremendous amounts of water in regions that are already extremely arid, which raises serious environmental and social concerns that we absolutely need to talk about. Australia, on the other hand, is currently the world's largest lithium producer, and they mostly mine hard rock spodumene deposits. This is more traditional mining. You dig up the ore, crush it, and process it chemically to extract the lithium. It's more energy intensive than brine extraction, but faster, and does not require the same water resources. China, while not having the world's largest lithium deposits, has strategically positioned itself to control much of the lithium processing and battery manufacturing industry, which gives them enormous leverage in the global supply chain. This is geopolitics in action, folks. Control the lithium supply chain, and you control a crucial piece of the future economy. If you're finding this deep dive into the geopolitics and chemistry of lithium fascinating, go ahead and hit that like button. It really helps the channel grow. And make sure you're subscribed so you don't miss our upcoming videos on other critical elements shaping our future. Now, let's talk about some of the other amazing applications of lithium that don't get as much attention as batteries, but are equally important. Lithium compounds have been used in glass and ceramics for decades. Adding lithium oxide to glass formulations does something remarkable. It reduces the melting temperature, makes the glass more resistant to thermal shock, and can produce glass with special optical properties. Those high-end cookware pieces that can go from freezer to oven without shattering? There's a good chance they contain lithium. Specialized glass used in telescopes, including space telescopes, often contains lithium compounds. The same goes for certain ceramics used in everything from high-performance spark plugs to dental materials. Here's another application that might surprise you: lithium grease. If you've ever worked on machinery, cars, or bicycles, you've probably used lithium grease without thinking twice about it. Lithium stearate and other lithium soaps, when mixed with oil, create greases that remain stable across a wide temperature range, resist water, and maintain their lubricating properties under pressure. It might not sound sexy, but lithium grease literally keeps the wheels of industry turning, from the bearings in wind turbines to the joints in heavy construction equipment. It's estimated that about 12% of global lithium production goes into these lubricants, which tells you just how critical this application is for industrial machinery worldwide. The aerospace industry has a special love affair with lithium as well. Remember how I said lithium is incredibly light? When you're trying to get something into space, every single gram matters. Spacecraft and satellites use lithium-ion batteries because they offer the best energy to weight ratio available. But there's more. Certain aluminum, lithium alloys, where small amounts of lithium are added to aluminum, create materials that are lighter and stiffer than regular aluminum. These alloys are used in aircraft fuselages, wing panels, and other structural components. The Airbus A380, one of the largest passenger aircraft ever built, uses aluminum. Lithium alloys extensively to reduce weight, which improves fuel efficiency and allows the plane to carry more passengers. SpaceX's rockets use aluminum, lithium alloys in their fuel tanks. When you're trying to revolutionize space travel and make it more affordable, shaving off weight with lithium alloys while maintaining structural integrity is absolutely crucial. Now let's venture into more cutting-edge territory, because lithium's role in future technologies is even more exciting than its current applications. Researchers are developing what's called solid-state batteries, which replace the liquid electrolyte in current lithium-ion batteries with a solid material. This could potentially increase energy density even further, reduce fire risk since there's no flammable liquid electrolyte, and extend battery life. Some of these solid-state batteries use lithium metal as the anode instead of graphite, which could theoretically increase energy storage capacity dramatically. Companies and research institutions worldwide are racing to make solid-state batteries commercially viable, and when they do, we could see electric vehicles with ranges exceeding 800-mile smartphones that last for days and energy storage systems that make renewable energy far more practical. The implications are staggering. Speaking of energy storage, let's talk about grid-scale batteries for a moment. As we transition to renewable energy sources like wind and solar, we face a fundamental challenge. The sun doesn't always shine, and the wind doesn't always blow, but people need electricity 24/7. Grid-scale lithium-ion battery installations can store excess energy generated during peak production times and release it when demand is high or production is low. Places like South Australia have built some of the world's largest lithium-ion battery installations, and they're proving that renewable energy plus storage can actually work at scale. These massive battery farms contain thousands of individual battery modules, all working together to stabilize the electrical grid. As battery costs continue to fall and capacity increases, we're approaching a tipping point where renewable energy plus storage becomes cheaper than fossil fuel power plants, which would fundamentally transform global energy systems. And lithium is right at the heart of this transformation. But I need to be honest with you about something, because no discussion of lithium would be complete without addressing the serious challenges and controversies surrounding its extraction and use. The environmental and social impacts of lithium mining are real and significant. In South America's Lithium Triangle, the extraction of lithium from brine requires pumping vast amounts of groundwater, approximately 500,000 gallons of water for every ton of lithium produced by some estimates. In regions that are already experiencing water stress, this is causing tension with local communities, particularly indigenous populations who have lived in these areas for generations and depend on limited water resources for agriculture and daily life. Farmers report that wells are running dry, and traditional livelihoods are being threatened. In some areas, protests and conflicts have erupted over mining projects, with communities demanding greater control over resources and a larger share of the economic benefits. The processing of lithium, whether from brine or hard rock, also involves various chemicals and generates waste products that need to be carefully managed to prevent environmental contamination. And then there's the question of what happens to all these lithium-ion batteries at the end of their life. Electronic waste is already a massive global problem, and as billions of devices and millions of electric vehicles reach the end of their useful life, we're facing a looming recycling challenge. Currently, only about 5% of lithium-ion batteries are recycled, partly because the technology and infrastructure for efficient recycling are still developing, and partly because it's often cheaper to mine new lithium than to recycle it from old batteries. This needs to change. Researchers and companies are working on better recycling methods that can recover not just lithium, but also cobalt, nickel, and other valuable materials from spent batteries. Establishing a circular economy for lithium and other battery materials is crucial if we're going to achieve a truly sustainable energy transition. I'd love to know your thoughts on this. Should there be regulations requiring battery recycling, or should we rely on market forces and technological innovation? Drop your perspective in the comments, because this is one of the most important conversations we need to have as a society. There's also the geopolitical dimension we touched on earlier, but it deserves a deeper look. The concentration of lithium resources and processing capacity in just a few countries creates potential vulnerabilities in the global supply chain. What happens if political instability affects a major lithium-producing region? What if trade disputes or conflicts disrupt supply? Countries that are heavily dependent on imported lithium for their electric vehicle and renewable energy industries could find themselves in a vulnerable position. This is why we're seeing a scramble to diversify supply chains, with countries like the United States, Canada, and various European nations trying to develop domestic lithium resources and processing capabilities, or at least secure reliable partnerships with producing nations. It's resource geopolitics reminiscent of oil in the 20th century. Except this time it's about controlling the resources that will power a decarbonized economy. Let me tell you about some of the more exotic and futuristic applications of lithium that researchers are exploring. In nuclear fusion research, lithium plays a fascinating role. Fusion reactors, if we can ever make them work at a commercial scale, would be the ultimate clean energy source, producing massive amounts of energy from abundant fuel with minimal radioactive waste. One of the leading fusion reactor designs uses lithium in a liquid form as a breeding blanket surrounding the reactor core. When high-energy neutrons produced by the fusion reaction hit the lithium, specifically lithium-6, it produces tritium, one of the hydrogen isotopes needed to fuel the fusion reaction. Essentially, the reactor would breed its own fuel using lithium. If fusion power becomes reality, and there's growing optimism in the field after recent breakthroughs, lithium would be absolutely essential to making it work at scale. Lithium is also being investigated for potential applications in next-generation air purification systems. Lithium-based materials can absorb carbon dioxide from the air more efficiently than many alternatives, which could be crucial for carbon capture technologies aimed at combating climate change. Imagine buildings, or even vehicles equipped with systems that actively remove CO2 from the atmosphere using lithium compounds. We're still in the research phase for many of these applications, but the potential is intriguing. In the medical field beyond psychiatric applications, researchers are exploring whether lithium might have neuroprotective effects that could be relevant for treating Alzheimer's disease, Parkinson's disease, and other neurodegenerative conditions. Some studies have shown promising results in animal models and small human trials, though much more research is needed. There's even been fascinating epidemiological research suggesting that populations with slightly higher lithium levels in their drinking water from natural geological sources might have lower rates of suicide and certain other mental health issues. Though this research is still controversial and not fully understood. The point is, we're still discovering new ways that this remarkable element might benefit humanity. Now, if you've made it this far, I want to ask you something. What do you think is the most important application of lithium? Is it the batteries that are enabling our transition away from fossil fuels? Is it the mental health treatments that have transformed millions of lives? Or is it something else entirely? Share your thoughts in the comments below, because I genuinely want to know what you think. And if you're enjoying this deep dive into the science and technology shaping our world, please consider hitting that subscribe button and turning on notifications so you never miss an episode. Let's bring this all together. Lithium element number 3. one of the simplest elements in the universe created in the Big Bang itself, along with hydrogen and helium, has gone from being a laboratory curiosity to one of the most strategically important materials on the planet. Its unique properties, being incredibly light, highly reactive, and capable of storing energy efficiently, make it indispensable for technologies that are reshaping civilization. From the smartphone in your pocket to the electric vehicles revolutionizing transportation. From psychiatric medications saving lives to aerospace alloys pushing the boundaries of flight. From industrial lubricants keeping machinery running to future fusion reactors that might provide unlimited clean energy. Lithium is everywhere, doing everything. But as we've seen, this lithium revolution comes with serious challenges. Environmental impacts, social justice issues, recycling needs, and geopolitical tensions are all part of the story. The question isn't whether we'll continue using lithium. We absolutely will. But how we can use it more responsibly, extract it more sustainably, recycle it more effectively, and ensure that the benefits are shared more equitably. As consumers, we have a role to play too, keeping our devices longer, supporting companies with strong environmental and social standards, properly recycling old electronics, and staying informed about these issues all matter. The race for lithium is, in many ways, the race to define the 21st century. Will it be a century where we successfully transition to clean energy and sustainable technologies? Or will it be marred by resource conflicts and environmental degradation? The answer depends on the choices we make now, as individuals, as societies, and as a global community. Lithium has given us incredible tools and possibilities. What we do with them is up to us. Before I let you go, I want to leave you with one final thought. The story of lithium reminds us that sometimes the most ordinary, seeming things, a soft, silvery metal that floats on water, can have extraordinary impacts on the world. Science is full of these stories, where curiosity, driven research into something obscure eventually transforms society in ways no one could have predicted. When Johann August Arfwedson identified lithium in 1817, he couldn't possibly have imagined that 2 centuries later, his metal from stone would be powering a global technological revolution and sparking international competition. It makes you wonder what other elements or materials we're overlooking right now that might be just as transformative in the future. So the next time you pick up your phone, start your electric car, or even use lithium grease on a squeaky hinge, take a moment to appreciate the remarkable chemistry and physics at work, and the complex global systems that brought that lithium from a salt flat in the Andes or a mine in Australia to the device in your hand. Science and technology aren't abstract concepts happening in laboratories far away. They're intimately woven into every aspect of our daily lives, usually in ways we never even notice until someone points them out. Thank you so much for watching this deep exploration of lithium and its incredible applications. If you learned something new today, and I really hope you did, please give this video a thumbs up. It helps more people discover content like this and supports the channel in creating more in-depth science videos. Subscribe if you haven't already, because we're going to be exploring more fascinating elements, compounds, and technologies that are shaping our world in ways both visible and invisible. And finally, I'd love to continue this conversation in the comments. What surprised you most about lithium? What questions do you still have? Are you optimistic or concerned about the lithium-powered future we're building? Your engagement and insights make this community special, and I read every single comment. Until next time, stay curious, keep questioning, and remember that science is the most exciting story being told, and you're part of it.